basically a way to describe how many independent directions or measurements something has. Every dimension is the degree of freedom, a way you can move or measure something without overlapping the other dimension or measurement. Imagine a dot is 0 dimension. Make it into a straight line. It is 1 dimension where you can move forward and backward. Now slide it into sideways to make a square where you have 2 independent directions to move, length and width. Now uplift the square into a cube. Where you have 3 independent directions to move. We all live in 3-dimensional space. This is length, front and back. This is width, which is side to side. This is height, which is top and down. 3 independent directions, length, width, height are scalars, which is only magnitude. These 3 are in different directions. Time is considered as the 4th dimension. If space is 3 dimension, adding time with it, making the 4 dimension space and time. Your location in the universe is not just where you are, but also when you are. Albert Einstein was the first to formulate the concept of 4-dimensional space and time as part of his general theory of relativity in 1915. Dimension is not 4. It is probably 3A dimension. I will explain it why in my upcoming videos. Some theories like string theory focus on extra dimensions which are beyond the visible 3. They are very tiny and curled up. As dimensions increases, information increases. As dimension increases, you can see your front as well as your back from one view. Dimension is how many independent directions you need to describe something fully. Maybe in higher dimensions you can read mind. These higher dimensions are not possible in our environmental conditions, so we don't notice them. Distance is a scalar quantity. It is how far apart 2 parts of any 1, 2, 3 of these dimensions. It is basically the amount of space between 2 locations. It can be positive or 0. The distance in 1 dimension. Examples. Imagine a straight line. Let's take it as a straight road which is 10 kilometers. Now you are here. 0.2 and your friend is at 0.7, the total distance between you both is 5 km. The total length of the road is 10 kilometers. In 2 dimensions, there will be length and width. Now imagine you are on a flat map like coordinates. You are here and your friend is here. The coordinates are x1, y1, x2, y2. The distance between you both is 2 x2 minus x1 plus y2 minus y1. Take the square root. Square is 9 plus 60 equal to 25. It is 5. The distance between you both is 5. In 3 dimensions, you will have length, width and height. Imagine you are here and your friend is here. These are the coordinates. Now the distance is root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1. 4 plus 9 plus 36. 7. Distance is 7. Length, width, height are directions. Distance is the measurement of how far something in this one or more directions combined. Displacement is the slight line changing position of an object, including both how far and in what direction it moved. That's why it's a vector quantity. It can be positive or negative depending on its direction. It can also be zero. How? If you start from here and take some distances, travel some distances, and you end in the same point, then the displacement is zero. If you start here and end here, it is positive, and if you start here and end here, it is negative. Now imagine if you start from the origin point and you walk 3 meters towards north and you take right turn 4 meters towards east. The total distance to travel is, by using Pythagoras theorem, is 5 meters. This is the straight line displacement to travel. It can be positive, negative, and if you again come to this point, it is 0. But the total distance traveled at that point will be and displacement will be 0 because you came to this same point. Displacement is the shortest vector connecting your starting and the ending coordinates in the multi-dimensional grid. Displacement is the shortest straight line path in the flat space. But what if the space itself isn't flat? In curved surface or curved space-time, the straight line doesn't exist in the Euclidean sense. The shortest path here is the geodesic. Geodesic is the shortest possible path between 2 points in the curvature of the space. In flat 2D or 3D space, these geodesics are just straight lines, but on a sphere, these geodesics are great circles. Example, the equator and the longitudinal lines. Einstein's relativity explains that geodesics are the object's path when no forces except gravity acts. In Euclidean geometry, for flat surface, the shortest path is a straight line, whereas in non-Euclidean geometry, for curved surface, the shortest path bends with the surface. You can measure it by simply subtracting the coordinates. You need to follow the curvature. On Earth, aeroplane route between 2 cities aren't straight lines on a flat map. They follow great circles. Geodesics on a sphere. The route to Mumbai to New York on a flat map, it looks like you should go straight west to the Antarctic. But in reality, the shortest geodesic are not over the Europe and near Greenland before heading to the US East Coast. Planet orbit the Sun by following the space-time geodesic caused by the Sun's gravity. If space has a metric, a way to measure the distance between it, a geodesic is the path that minimizes the measured length.